Good morning, and I'm John Bedewick, and welcome to my sixth video assessment problem involving slope fields, in which we are given the differential equation dy over dx is equal to x over y.
Part A asks us to find the solution curves to the point 1, 2, and 3, -1. Now first, I found the solution curve through the point 3, -1, as shown by the red/blue dot. To find the shape of the curve, I just followed the flow of the slope field, in which I found the shape of the curve to be an hyperbola. Next, to find the point 1, 2, I first marked it down as a red, as it's kind of hard to see in the orange highlight. Then, using the flow of the slope field, I found the shape of the curve to be more of a parabola. Now, the parabola has a horizontal asymptote, as shown by a horizontal line on the slope field. And the point 3, -1 curve actually has a vertical asymptote because it has a vertical line on the slope for the y-intercepts.
Part B asks to write an equation for the line tangent to the solution curve that passes through the point 1, 2.
The equation used to find the line tangent to the curve with point 1, 2 was a point slope form, or y equals mx plus b. In this situation, m is the slope, or the change in y over the change in x, which is actually, the equation is given to us as x over y. So when we plug in our value of 1, 2, we get our slope to be 1/2, in which we plug it back into the equation to get y equals 1/2 x plus b. Now to get b, we plug in the point 1, 2 again into the equation, in which we find b is equal to 1.5. So our equation for the line tangent to the curve with point 1, 2 is y equals 1/2 x plus 1.5.
For part C, we have to find the particular solution of y equaling to f of x to the differential equation with the initial condition of f of 3 equaling -1, and to state its domain.
For part C, I was given the original equation of dy over dx is equal to the x over y. Now, I first set y equal to x, and from there I integrated to get 1/2 y squared is equal to 1/2 x squared plus c. Now, when finding the initial condition of 3, -1, I plugged it into the equation to find c equal to -4. From there, I then isolated y to get the equation to be equal to y equals the square root of x squared minus 8.
It is also noted that the domain of the function is x is greater than or equal to 2.8284, or the square root of 8.